Hello class, I've got some information here that will help you be successful on the midterm exam and also through the rest of the course here, because we're going to be seeing a lot of numbers that use metric prefixes as are put in the engineering notation form. So let's take a look at what that means. If my slides will move, there we go. Engineering notation. We use engineering notation for most electrical quantities. This allows us to express very large or very small numbers in a simpler format. Only the powers of 10 that are multiples of 3 are used in engineering notation. Each power has a standard prefix that can be used with any standard units, including voltage, current, resistance, inductance, and capacitance. And we're going to be learning about those two quantities in the next 4 weeks of the class. The prefixes are listed on the next slide. So let's take a look at them here. And we start with the very small numbers and go up to the very big numbers. So we have pico or pico, nano, micro, milli, kilo, mega, giga, and tera. Now there are units if you're doing like chemistry and some other things like that. There are units between where it says unit here 10 to the 0 power and kilo 10 to the 3rd power, but we don't use those in electronics, so you don't have to worry about those. So let's look over here. You have the symbols here, and those are pretty important, and notice these are lowercase and these are uppercase. Well, actually, K is not supposed to be uppercase. It's usually expressed lowercase. But the real important thing here between the cases is between milli and mega. Milli is lowercase and mega is uppercase. Just remember that. So you don't get those two confused because there's a big difference. Now, this column here, convert to conventional notation. If we have a number in pico and we have to move, if we want to convert that to a whole number, we have to move the decimal 12 places to the left, and so on and so forth. And then if we're down here, if we have a number with mega and we want to convert that to a conventional number, we have to move it 6 places to the right. And I'll show you how that works here in the next slide. So we have, we're going to convert 8 picofarads to a conventional number. We have to move the decimal 12 places to the left. So there's our number, 8 picofarads, and we write it out here on the paper, write the 8, and then start moving over. So you would start with your decimal point right here, and you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And so our new number would be 0.0000000000008 farads. So as you can see, it's very much easier to write the number 8 picofarads and say the number as it is to write all those zeros and 8F. So that's really clearly shows a benefit of the metric prefixes in engineering notation. So let's look at moving the decimal point to the right to convert a number greater than 0 to a conventional number. So convert 10 megohms to a conventional number. We have to move the decimal 6 places right. So there's our number, 10 megohms. And let's count now here. We have our number 10, and then we go 1, 2, 3, 4, 5, 6. So our new number is 10 million ohms. Not as clunky to say as the numbers that are smaller than 0 or to the right of the decimal, but still easier to write and put on a like electrical schematic and things like that. So this is engineering notation. Now let's look at it a little deeper here with some examples. converting engineering notation to conventional notation. Example 1, convert to conventional notation. We have a number here, 4.32 kilovolts, or that's 4,320 volts. The letter K indicates kilo, meaning 10 to the third power. Therefore, the decimal must move right 3 decimal places. 1 0 was added, so we had to move over. So we were here. We have 1, 2, 3. So we had to add a 0 there. The decimal can be eliminated because there are no digits to the right, so we didn't have any more digits. Or a simpler way we can do this, if you really understand how these numbers work, you can use this. You can multiply the engineering notation by 1,000. So 4.32 times 1,000 equals 4,320. And remember, kilo means 1,000. Okay, let's look at another example. Convert to conventional notation, and we've already looked at this. 15 million ohms equals 150,000,000 ohms. The letter M indicates mega, meaning 10 to the 6th power, or 1 million. Therefore, the decimal must move right 6 decimal places. 6 zeros were added. Or we can multiply the engineering notation number by 1 million. 15 million times 1 million equals 150,000,000 ohms. Okay, let's look at another one. Example 3, convert to conventional notation. 4.25 milliamps equals 0.00425 amps. And again, the metric prefix engineering notation form is a lot easier to write and to say. The letter M, lowercase m, indicates milli, meaning 10 to the negative third power. Therefore, the decimal must move 3 places left. 2 zeros were added to the left of the 4. Or, if we just want to use math, divide the conventional notation number by 1,000 because milli is 1/1000ths, in the 1/1000ths range. Converting conventional notation to engineering notation. 1,000 volts equals 1 kilovolts. 10,000 ohms equals 10 kiloohms. 0.003 amps equals 3 milliamps. 0.001 amps equals 0.1 milliamps, or 100 microamps. Now here, especially with these smaller numbers, a lot of times they'll do this because this is a simpler form here. 0.1 milliamps is in a simpler form than 100 microamps. But this is not really true engineering notation form. So just so you know, remember what I said. It's the same, only different. This is the same number. All 3 of these actually are the same number, but they're different because they're written differently. But same values. Okay. So here we got another one. We're going to convert from conventional to engineering. So we have 10,000 volts equals 10 kilovolts. The decimal must move left 3 places to produce a number in the range of greater than 1 and less than 1,000. The prefix K was added. The trailing 0 can be eliminated. Or we can divide the conventional notation number by 1,000, because we know 10,000 kilovolts. We know kilovolts is 1,000, so if we divide 10,000 by 1,000, we get 10 kilovolts. Convert this number to its simplest engineering notation form and assign the correct metric prefix. Milli is the simplest form, and that should be lowercase on there. I just noticed on the slide it changed it. Milli equals 1/1000, so 0.007 times 1,000 equals 7. So the answer is 7 milliamps. Remember, only powers of 10 that are multiples of 3 are used in engineering notation. So there we go. There's several questions on the midterm, and I'll be giving you some problems to work on this in class this coming week. Everybody have a good rest of the weekend if you're watching this on Sunday, and I'll see you in class next week. Thanks for watching.